Good day, viewers. My name is Delwit and I welcome you to Delwit Electrical YouTube channel. In our previous videos, we talked on how to size the inverter systems, the solar panels, the battery, and the charge controller. But today, we'll be talking extensively on how to size your generating set. We would know that previously, the high cost of diesel, petrol, which is popularly called fuel or PMS, is on the high side. Hence, we should know how to appropriately size the generating set in order for you to not to oversize or undersize your generating set. If you actually oversize the generating set, it has an effect because you consume more fuel. If you undersize the generating set, it will lead to the damage of the coils of your generating set. So now, let's talk of how the steps to be taken to size your generating set. The first is to determine the load consumption of your building. So if you intend to use the generator of a particular building, you have to know the total load capacity of that building so as to appropriately size what kind of generator you are bringing to the building. Secondly, you have to know the kVA rating of the generating set that you intend to use. So from your previous calculation, which is your load consumption, you could derive your kVA rating. Thirdly, you have to take 1/3 of the required consumption. So if you add 1/3 to your total consumption, you have that is what is the rating that is required. Because if you use your total load consumption, you know that your generator is not supposed to be sized to full capacity, so there should be an allowance. So 1/3 allowance is required. Then finally, you have to take cognizance of the class or phase of generator that you need to use. So this class of phase is to know if actually you require a single phase or a three-phase. So it depends on the kind of load you're using in your building. So if you're using a single phase load throughout, then you have to use a single phase generator. But if you're using a three-phase load, that means you have to require a three-phase generating system. So let's go to the determination. Important. Your load consumption in the building is very, very important. There's various types of load in the building. You have your lighting system, your water heater, your AC. All these are various loads in the building. So you have to know their various ratings, which every equipment has a nameplate. And on the nameplate, you have their rated capacity. So, but unfortunately, most times you see this rated capacity in kilowatt or in watt. If you see them in kilowatt or watt, you are lucky. Sometimes they will only give you the amperage, that's the current rating and the voltage rating. So if you are giving the wattage or you are giving the current, what you are supposed to do is for resistive load, you have to use the amps times the volts. The amps times the volts will give you the wattage for a resistive load. But for a reactive load is going to give you the amps times the volts times the load factor. So how can you determine the load factor? Load factor is usually the total kilowatt hour for the previous month divided by the peak demand for the period times 30 times 24. So when you do this calculation, you will have your load factor. Load factor is very important for a reactive load because if you don't take this into consideration, you might not arrive at the right calculation. So the list of equipment in the next slide, you will see a table that gives the power rating of various household equipment. We do not take cognizance of diversity factor. Diversity factor is the factor that takes cognizance of the fact that you're not going to use all the equipment, your household equipment, simultaneously. So some might be put up, some can be put off. But for the essence of this calculation, we are omitting diversity factor. We are assuming that all appliances in the building will be used simultaneously. So you can see this is the appliance, the type, and the wattage that is required. For pressing iron, we have the steam type, we have the dry type, 1200 or 2000 watts. So you could go through this table whenever you want to carry out your load calculation. I believe that this topic has been very, very interesting. It's quite interesting for you so far. If it's interesting, please kindly click on the subscribe button below to subscribe to our YouTube channel. For Click and also click on the notification icon to get notified whenever subsequent educative videos on electrical is being posted on our channel. So we'll continue. Now, once you have gotten the total wattage, you can then use that value to get your KVA rating. So all those equipment that I've given to you, you use it to calculate, you sum them one after the other, and you get your kilowatt. So once you have gotten your kilowatt, you are going to divide it by the power factor. So your kilowatt that you calculated divided by the power factor. Usually, we normally use 0.8 as our power factor. That will give you your KVA. So with that KVA, you are sure you have gotten a value. So once you have gotten that KVA rating, I told you initially that you are going to use one third of the calculated load consumption. So one third times 100 is 1.33. So 1.33 times the total calculated consumption, you will get a value. So that value will now be your rated capacity. Then the last one we're going to talk about is the class. Like I said, the class or the phase gives you either a single phase or a three phase. So if your load, you don't have any three phase load, you concentrate on a single phase generator. But if you have a three phase load, that means you are going to go for a three phase generating set. So let's take an example. Let's have an office complex that has three 1.5 horsepower air conditioning units, one lathe machine which is rated 5 kilowatts, three computer systems. The total load of the entire office complex is 300 watts, and you have a pumping machine for the water for 1 horsepower. Now, the solution will be 1 horsepower, as we know, is 746 watts. So, and 1 horsepower, and we have we have 1.5 horsepower. So, when you cross multiply, 1 horsepower is 746. Therefore, 1.5 horsepower will give you 1.5 times 746, which is 1119 watts. But we have three ACs, so that means 3 times 1119 will give us 3357 watts. That is for the air conditioning unit. For the lathe machine, it's already SPC, 5 kilowatts, which is 5 times 1000, which is 5000 watts. For computer system, most computer systems are being rated 120 watts, not laptops. Laptops are usually 80 or 90 watts, but for computer systems, desktop, 120 watts. So if we take it as 120 watts, and the question says there are 3 times 120 will give us 360 watts. The total lighting load for the office complex is 300 watts, and our water pump is 1 horsepower, which is 746 watts. Therefore, our total load will be 3357, which we got initially, plus 5000, plus 360, plus 300, plus 746. So when you add all this together, this 3357 is for the AC, this 500 is for the lathe machine, the 360 is for the lighting points, the 360 is for the computer system, the 300 is for the lighting load, while the 746 is for the water pump. When you sum all this together, you have 94331, which is 9.433 kilowatts. I guess we got that. So having 9.433, we know that generators are usually rated in kVA. So your kVA is equal to your real power over your power factor. And I told you that our power factor to be used is 0.8. When we divide 9443 by 0.8, you have 11.8 kVA. But generators, as I told you initially, are not allowed to operate at full capacity, because if you operate at full capacity, it will knock almost immediately when it's a little bit overloaded. So it's usually advised to be operated at 1/3 its full capacity. Therefore, the required generating capacity is 1.33, which is 1/3 times 100 times 11.8, which is our calculated load. That will give us 15.7 kVA. So the required generating set capacity should be 15 kVA, because 15.7 or 16 kVA is not found in the market. So we're going to go for a 15 kVA generating set. And as we are seeing that all our equipment are usually at single phase. So I want to get a single phase generator at 15 kVA capacity. So I believe that this has been very educative and it has been able to show you how to choose and size the generating set so as to rightfully get the optimum performance that is being required. If this video has been useful to you, kindly click on the subscription button and subscribe to our YouTube channel. Thank you very much.